Okay, so welcome to B Period Stats. It's Monday, May 18th, rainy, dreary day. Couple things, just sidebar discussions may not have heard, but Father Adrian passed away at 2 o'clock this morning. So I don't know if Mr. Graves, anybody's put anything out. And the word is that the monks are going to have a kind of a low-key private ceremony during all this COVID garbage, and then maybe something larger and more open, later this summer or early fall. So that's kind of the downside of today. The upside is right now there's a huge crane out by the new gym, and they're putting a huge copper cross on top of the bell tower, which looks pretty cool. And they have drones up there filming it and all. So that's kind of neat. Progress. All right, so this is our next to last stats class. Our original plan was to go over the sample distribution of sample means exercise from using 4, 6, and 8 population from last week, and also the end of lesson problem exercise from last week. But only one person submitted that. And so, if I go ahead, I can post it and show it to you all, but once I post it and show it to you all, it's kind of a moot point for you to submit work that you've just copied off the screen. So I'm a little at odds of what to do reference that. One option is, the one was due the Monday exercise was due Tuesday, and the Wednesday exercise, I think, was due either Thursday or Friday, and the only one I've received is Mr. Handy's. So, not sure. Everybody else got lost in the sauce somewhere. This really said twice a week schedule of classes. So, one option, just kind of thinking out loud, is there's one more section to this chapter, 7-3. All three of these sections are very, 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 very similar. And I've got the PowerPoint up and ready to go. It's only 8 slides, so it's a very small chapter. This is a quick chapter, and this will actually wrap up chapter 7, and that's as far as we're going to get. And there's one set of let's see, one page front and back, about a dozen problems from this section I was going to give you today. So one option is for me to go over section 7.3 and talk about it. It's, like I said, 7.1, 7.2, and 7.3. Each of those 3 sections are kind of keep repeating ourselves, so it's not earth-shattering, groundbreaking new material. And then let you do that exercise as well as submit the other 2 before Thursday, and then we go over those 3 exercises, 2 from last week and this exercise on Thursday. I was hoping to do a little quiz on this section, this test, just because I want to do a test at this late stage of the game. But there's no time to recover if it happens to. Always cover it. There's little time. I don't like to have a day of reckoning at the very, very end of the quarter. You tell me how to proceed. If I put the answers to the other problem sets on there, I don't want to give you guys that didn't turn in a 0, but once I put the answer keys there, it's, I can't, it's not fair to.
I'll do them. So I don't want to get a 0 on them.
So, I mean, the option is if you guys think you're going to submit them, I can just go over section 7.3, which is, again, is very similar to 7.2 and 7.1, and post that problem set, and then you can do all 3 if you haven't done all 3 between now and Wednesday night, so I can look at them Thursday morning before class, and we just going to wrap up those 3 problem sets on Thursday.
I'll do that.
A day, a week, a month, a quarter, and a semester, and a year. At the best, I'm kind of leaning that's maybe the most logical, fairest way to go. I'm open to suggestions.
7.3 sounds good.
But yeah,
right.
7 down.
Good. So let's do that. But the other two things are on Blackbaud. You can download them. If you can't, for some reason you run into technical difficulties, some of the things I've started putting in PDF formats, and I don't know if I did those or not. That was, sometimes Blackbaud doesn't like Microsoft Word. So if you can't get them, just shoot me an email and I'll send you a PDF version. All right, so let's do, share my screen. And let's see if I can do this. Come on, there we go. Everybody see that? 7 sample variability on your screen. Yes.
Yes.
All right. So just as a kind of review from what we talked about last week was the sampling distribution of sample means, which in a very brief, concise summary or description of what that is we take multiple samples of the exact same size from the population that's hopefully random and not biased and very representative. And then we take the means of all those samples and we analyze the means, which as we increase the size of each individual sample, and they all have to be the exact same size, everything's going to trend towards a standard normal curve, and then you can do all the standard normal curve probability calculations. That's a real concise explanation of that. So here we go. All right. All right. Says when the sampling distribution of sample means is normally distributed or approximately normal, which means the same thing, we will be able to answer probability questions with the aid of the standard normal distribution, which is doing all that, calculating how many standard deviations we are from the mean, getting that area under the curve, which directly corresponds with probability. All right. Nothing new or exciting there. Like I said, this is a strange chapter in that all 3 sections just kind of keep saying almost the same thing over and over. But it definitely reinforces the information and drives the point home. So as the width of the curve narrows, the height has to increase because remember, under the curve, under that standard normal curve, if we add all that volume up and it fills from left to right, it's going to fill from left to right. Underneath that curve is always going to be equal to 1 if we add all that up. And that's why if you get out here where you're 3 standard deviations below the mean, the probability is going to be real close to 0.000, right? Once you get clear over on the right side, it's going to be real close to 0.999, right? That's actually 9. All right, so remember from previous sections when we started increasing the size of the sample, it started making this thing go up. All right, and it started reducing the standard deviation, or as we call the standard deviation of the sample mean standard error. I'm not going to get hung up on the term. All right, which means standard deviation is a measure of dispersion. If that keeps shrinking, which it will, because remember it's the standard deviation of the population divided by the n, or the square root of n. And as that n increases, and we divide that into the standard deviation of the population, it's going to get smaller and smaller. And as standard deviation decreases, it means the data starts, moving collectively towards the mean. And that's what that's saying. So if the error under the curve, whether it's this broad curve is 1 and under this very narrow curve is 1, if these sides start pushing in, then it's got to go up because the error under the curve equals 1, right? And you'll see, in the second one, maybe, 90% of the data is within 1.5 or 2 standard deviations, excuse me, 2 standard deviations of mean, as out here where your 3 standard deviations either side of the mean. Again, all that, everything I just said is kind of review. Does that make sense? Or just kind of recap some of the stuff we've been talking about for quite some time. Any questions? Any confusion I can clear up? All right. So we're halfway through the slides because there's only 8. Let me see if I can get this thing to move. Come on, move slide. There we go. All right, it says kindergarten children have, and this is just an example, a real life example to kind of drive home some of the points we just talked about. So kindergarten children have heights that are approximately normally distributed. All right, so it's a standard deviation. All right, and so we've got a mean of 39 and a standard deviation of 2. All right, so for the population, if we say everything's within 3 standard deviations of the mean, that means everybody's going to be between, and I'm rounding things, 33 to 45 inches tall, right? For the population. Within what limits does the middle 90% of the sampling distribution of sample means for samples of size 100 fall? All right, so we're gonna focus in on the middle 90% of our data. Okay, we know how to do that. I'll refresh your memory on that. And we're going to have a sample size of 100. So that's our n equals 100. So that's huge. So you know this thing is going to be really steep and really narrow. All right, really steep and really narrow. Because 100 is huge. All right, we good so far? So let's look at this, analyze a little closer. All right, the 2 tools we have to work with are the Formula 7.2 and Table 3. All right, and you know what Formula 7.2 is. It's the how many standard deviations are we from the mean. All right, that's that x minus x bar over the standard deviation. That's the formula. Talk about the table in Appendix 3 is the table we've been using that does everything to the tens of thousands. It's the same table we've been using for 2 to 3 months, right? So let's take a look at what they're talking about. Since the formula relates the key values of the population to the key values of the sampling distribution, and Table 3 relates area z-scores. All right, so that's the z-score for the middle 90%. It's negative because of being symmetrical. It's the exact same value, but opposite sides, which makes sense, right? So we know right here how they got this is the point of, if the middle 90% is right here that we're looking at, there's 10% on outside of that 90%. So there's 5% over here, 5% in this area here, and there's 5% in this area here, which is 0.050, right? So that's where they got the negative 1.65. If you look at that table, if you happen to have it sitting there, and look at this value right here, if it's not exactly in the table, it's real close, and it's real close to that z-score of negative 1.65. And since we know it's symmetrical, we know that its counterpart is 1.65, or this right here would be, because if you looked at the error and found this would be what? 0.9. Let's see here. Let's see, 0.9. Yeah. Yeah, this thing's real hard to roll with. So if we would look at 0.9500 in that table 3, or the table that you have, that would correspond to negative 1.65. Good so far? Makes sense? So this is kind of review. I'm not saying anything you haven't heard before. All right, so let's go to the next one. Come on. Let me clean up my scribble. All right. So, let me see some here. Come on. See if it's going to see. Okay. Yeah. So, let's see. How's the best to do it? Yeah, let's just do this. So, this is what I was just talking about. That value right there corresponds to a z-score of 1.65, actually negative 1.65. Because it's a negative 1.6. We're just looking at a little piece of that big table, right? And so that's the negative 1.65. So that's that very left kind of edge of that middle 90%. All right. Good so far? All right. So so there's the formula, which so it's X bar minus the mean, all right, over the standard deviation of the population divided by our sample size. Remember, this right here is the standard error of all your means. Remember, and as this gets bigger, this denominator gets smaller, all right? And the data kind of coalesces towards the mean. Just to show up. So here's our formula. So we got, let me get my pen back working again. All right, so that's the left edge of that middle 90%. That's the right edge of that middle 90%. All right. Everybody good? Let me see some here. Let me just see what they did here. Okay, I see what they did. Okay. Okay. Let me just do my scribble. Let me scribble here. I want to talk about one other thing. All right, remember this 2 here, this 2 here and 2 here is the standard deviation of the population, and the 100s is our end, all right? And so we're trying to find the mean of the mean of the means, I guess is one way to describe that. All right, let's see if I can get this thing to go. So here we go. We're going to do the calculation. All right, let me just see what we did. All right, so all we did was we multiplied both sides by the 1.65. And we came up with the 39 minus and plus 0.33. And we came up with the 38.67 and the 39.33. See if it'll show it graphically. Okay. Let me just backtrack here. Come on. All right. Let me blow this thing back up. Okay. So what that, sorry, my pen's not cooperating. So what we just did here is that, let's do this. Let's do this here. What that calculation just did for us. Let's see. Backspace. Bear with me. Instead of scribbling. All right. All right. So what we just did there is the mean for the situation was how would that work? Now my pen's gone totally out. I wonder why it's doing that. All right, so it was working. Let me try one other thing so I can get my pen to work again. So I got ran out of ink. It's not going to work. Okay, so the mean was 39, right? It was. They told us that for the population, and the mean of the population and the mean of all your samples should be identical or super close if you did some rounding. So the mean was 39, and we're just plugged in real data to this generic standard normal curve. And with our calculations there, we determined that the lower edge of the 90% was 38.67 inches in height, and the upper edge of the 90% was 39.33. So if you look at it, you know, that's a very small spread there. If you look, 90% of your samples are within what, 0.66 inches of each other, right? Try one more time to see if this will work. That's weird. Pen's not working at all. Does that make sense? I can't draw on it for some reason. My pen's going out. But what we just did there was, you already knew the mean was 39. They told us that. The standard deviation was 2 of the population. The standard error, I forgot what it came up to be without progressing through the slides. But for this particular situation, 90% of your samples of the children that were determined their height was within, really, like I said, 0.6 inches of each other, which is a very, very small spread, very small variability, very small dispersion. Does that make sense? Let me see if the slide won't even progress. Everything froze. Let me, can't even come out of the stop share. What the heck? Bear with me. Yeah, it won't even let me stop share the screen. Let's see here. I don't want to lose you. I'm trying to figure out how I can kind of back up. Yeah, my mouse is. All right, I think we're frozen in time. All right. So that kind of leaves us a little bit of a dilemma. I can't move this. I can't stop my screen share. Let's see. Let me see if that'll work. Let me just see if I can do one other thing, see if I can undo this. Nope, that's not going to work. Huh. That's really odd. I have no control of anything, literally and figuratively. Nope, well, let me do it. Okay, so we made it through all 8 slides, I think. Let me just double check. I got a copy here. See if there's anything else to mention. We did that. All right, so bottom line is that X is greater than 38 points, greater than or equal to 38.67 and less than 39, less than or equal to 39.33. All right, and that's what we just did there is real similar to the exercise from today. So since I can't unfreeze anything and have no control over my keyboard, you got to take a look at it. What I'm going to do is, hopefully, give me about 10 or 15 minutes. Hopefully he's down there. He can untangle the difficulties with my computer, and I will load the PowerPoint slides that you have that we just went over on there and the problem set. All right. So if you would, between now and Thursday morning, the sooner the better, because then I can look at some of them prior to just before class and actually Wednesday morning. I can go over the two problem sets from last week, which was the sample distribution of sample means using the numbers 4, 6, and 8. And then there was a series of about 8 questions that were into lesson problems for 7.2. Plus then these, this is section 7.3 I labeled as last problem set. Literally, figuratively, I'll load that hopefully here. If you can untangle the, maybe my thing's got coronavirus. I'll get that loaded. And if you submit all those, and on Wednesday, we'll go over those 3 problem sets. Fair enough? Questions, comments, concerns? Everybody can hear me all right? We're still right? That is really odd. I don't know what happened. I was typing. Trying to retrace my steps. All right. All right, with that being said, since I can't move my slides, I can't come out of this. All right. Hopefully give me about 15 or 20 minutes, see if we can untangle what's going on here. And I'll get the PowerPoint slides loaded in Blackbaud and this problem set that covers a section that we just went over. So Mr. Handy just has this problem set, and everybody else, if you want to do the 2 from last week in addition to this one, just make sure you do it. Hopefully early before Wednesday morning so I can look at it before class on Wednesday. All right. Any questions or comments? Anything I can reiterate or go over? They told us this morning that I'm still doing office hours 2 to 2:30 every day this week. Friday we don't have school at all, so it won't be the 9 to 10 office hours on Friday. If you want to go back through Blackbaud, they said all late work has to be submitted by Thursday. There's nothing, unless there's some huge extenuating circumstance, all late work has to be in by Thursday. Pretty much no ifs, ands, or buts. All right. Questions, comments, anything I need to cover? Okay. Sorry for the freeze up. Not sure what happened, but we did get through all the material. Just check back on Blackbaud. Hopefully by 11 I'll get this figured, or have the IT guy figure out why everything's frozen. And one way, shape, or form, I'll get this stuff loaded on Blackbaud by 11. All right. Otherwise, any questions? Otherwise, we'll see you on Wednesday morning for the last class at 10 a.m. Fair enough? All right, we'll see you Wednesday.
Sir.
Uh,
Good day, sir.
You too. Let's see.